Hey guys, welcome to Calc. This is section 1.1. Really short section, so I'm going to try to attach 1.2a with this. Okay. Calculus is
Mathematics of change. Well, mine, that up verbatim, not a problem.
between pre-calc and calculus. Okay, there are what we call limits of functions. And we'll define limits as we start going through here. As we paged up. Yeah, the PDF. Sorry, the page is not. See if I can grab it. There we go. Okay. So look at the following examples to see some differences between pre-calculus and calculus. What you'll see here is, okay,
You can actually solve for every point when it's continuous.
with differential calculus, we can actually find the limit or what that value is here at that open circle. Pointer.
So as you see, as this goes to this point, it's open, but we can actually solve that point using calculus.
Okay, slope of a line.
It's linear, it's simple. What if it's the slope of a curve?
Okay. What if we want to find the slope of exactly of a tangent line? Okay, to a curve. You can do that. Whereas before you would need two given points, then solve, and so on. You got an instantaneous rate of change as opposed to an actual rate of change. Okay, we can figure out the rate of change at any point. Here we would need 2 points to do that. Okay, and then it would be between those 2 points instead of being instantaneous. Okay, but here's some other examples. What if it's a non-constant force here, whereas this is a constant force? And so on. You can see how calculus would be more applicable to real-life situations because things don't stay the same. Plenty of questions I'm sure are coming to mind. How did they come up with it would probably be a good one. Right? And how do we actually solve for it? And that's what we'll learn throughout the year. Now, what does the lower limit appear for the main swing 100 meters? How did you determine this? Well, let's take a look at this graph quick. Okay. The data will be basically displayed here in a second. We want to know what the lowest limit is after this loads up. So here comes your data. There are your points. Okay? So you can see as this is going throughout the years, it keeps getting lower and lower and lower. What's the lowest limit? Well, what's this lowest point here? So we would say the lowest point is the last point. I'm going to need my pointer here to scroll down so we can actually see that last point, which is in 2009 at 46.91. Because we don't have an equation here, okay, the lowest number verbatim literally is 46 seconds, 0.91. So we jump back here. For all intents and purposes right now,
We would say, okay, 46.91 seconds would be your lowest, your lower limit.
as we define what a limit is, you'll actually see that that's going to be a little different. But that's all you're supposed to do for the first section. When you see me again, or hear from me again, I should say, we'll be at 1.2. So we'll see you shortly.